Good morning, class. In the previous classes, we have discussed regarding the initial construct. So, totally, we are discussing regarding the behavioral modeling. In the behavioral modeling, we have basically two main constructs. One is initial construct, and another one is the always construct. In the initial construct, we have seen that we can have uh, we will be using for the assignment of values to some variables. We will be generally using this initial, and at the same time we can also assign some value with some amount of delay. That thing what we have seen in the initial statements, right? So not only that, instead of having multiple number of initial statements, we can also, that means if you want to create some delay and if you want to give initialize something, we use this instead of using these two in two different statements, we will be using the both and combine the both, and we will be using in a single statement. That thing what we have seen in the initial statement. And also not only that, initial will be having begin and end also. So we can have the scope of some of the internal variables up to that begin and end. Actually, we will be actually using only for this always. Generally, this begin and ends. That thing we will see in this in the discussion detailedly. So first we see this always construct. This always process signifies the activities to be executed on an always basis, right? Okay. So what we have seen, first one is the initial. That means it can be executed only once. It is sufficient. Okay. It will be executed if it is executed only once. That means if you can assign some value to it. Okay. You can assign some value to it for some part of time up to that scope. Now, when we go with this always, see, whenever there is a change on something, it has to be observed. That is called this. You can see here, always process signifies the activities to be executed on an always basis. Okay, the construct itself is saying that it is working on always basis. Its essential characters you can see all any behavioral level design description is done using an always block. Okay, when we want to describe our program with the help in the behavioral level modeling, we will be using this always block. So the process has to be flagged off. What is this flagging of? Flagging of what is this flagging of? Always means that means we want to execute these statements always, every time. Always means here every time. Okay, but it has to be executed every. If it is continuously executing the same set of statements, we can't terminate the program. So what we have to do is we will assign some content. That means it has to work for this event, or it has to change the output based on the change in this particular input, like this. Okay, that is flagged off by an event or a change in a net or a register. Otherwise it ends in a stalemate. This means that the process has to be flagged off by an event or change in an init or in a register. If it is executing continuously, it is also a problem for us, right? That means we have to specify it has to observe the changes for this variable, and it has to execute the statements. That thing we can see here in the examples, right? The process can have one assignment statement or multiple assignment statements. Okay. In the previous class, we have seen the generalized construct for both the initial and also the always, right? Okay. Whatever the case may be, we can have a single assignment statement or multiple assignment statement, both in the initial and the Always, right? So when we have multiple number of assignment statements, we will be writing all those multiple assignment statements in the begin and end. Begin we will be using the, so in between the begin and end, we will be writing the, in this begin and end we had write the statements. This multiple number of assignment statements, right? Whatever the content we write, whatever the content we write in between this begin and end, they will be executing sequentially, right? Okay, rest all others will be executing concurrently. Okay, whatever the hardware description language may be, mostly we try to execute all the statements at a time. But executing of all the statements at a time will be possible only if all the statements are independent. But some of the statements will be depending on the others. So that means they have to be executed sequentially. But that is the case. Well, how we got this behavioral modeling, either in the VHDL or in the Verilog HDL or any other language also, right? So that means always, generally, always at the rate some positive edge of the clock or negative edge of the clock, like that. At the rate we will be using. So what is this at the rate? It is nothing but the control, event control. This always block is executed repeatedly and endlessly. Actually, it is necessary to specify a condition or a set of conditions which will still the system to the execution of the block, right? So it means you want to flogging off. You want the statements to be flogged off, right? That can be done with the help of this at the rate symbol, right? Such a flogging off can be done by specifying an event preceded by a symbol at the rate, right? The event can be changed in the variable specified in either in a single either direction or a change in the specified direction, right? So what you have to see is just like you create, you write here always at the rate into its clock. That means that particular part or that means the statements which are between the begin and the end of this particular always block, they have to observe the change on the clock, that too in the negative edge of the clock. Only at the negative edge of the clock there will be, if there are any changes, it has to observe at negative edge of the clock, and then that has to be executed, and the inputs will be varied and correspondingly the outputs will be varied, and that can be noted down. That means output will be seen in the simulation result, right? So if at the rate negative edge clock, at the rate positive edge clock, that means it will be for positive edge of the clock. If it is at the rate of the clock, that means it will be executing for both the positive edge and negative edge. Okay. For every change in the specified, that means for every change in the clock, there should be execution, or there should be noted. You have to note that are there any changes in the inputs. Okay. For every positive edge or the negative edge, you have to identify whether there are any changes to the some of the variables specified there. So not only that, we can also have events. Previously it is for the clock, now it is for the event or some combinations of events, right? So always at the rate PRT or clear, that means the the execution of the given and statements between the begin and the end, they have to be observed and it has to be executed correspondingly based upon the path or the clear, PRT or clear. If there are any changes, if there are any changes in the clear or preset. Mostly PRT may be the preset. There are any changes in the preset or clear that has to be observed, and the given set of the statements has to be executed, right? So not only that, you can also have this positive edge clock 1 or negative edge clock 2. That means you want to observe the changes in the positive edge of the clock 1 and negative edge of the clock 1. You have to observe the both, and if there is any change in any one at least, there should be change. There should be change in the output, right? Based upon the change in the inputs, what we got there. So these events, what we specify, the events what we specified here, preset or clear, or any other events, events can be, they have to be specified as a registered or integer result, or it has to be some signal or a net, okay, and they have to be declared beforehand, right? They have to declare before itself only. So we can't give some algebraic expression. We can't give some algebraic expression or logical expression as an event. When that means we can't write always at the rate in the brackets. We can't say if a is equal to 2, if a is equal to 3. Not like that. It has to produce on a. That's it. That means if there is any change in the A, correspondingly there has to be change in the output with respect to if there is any changes in the inputs. Okay, that means it has to be declared in the beforehand. Okay, no algebra or logic operation is permitted as an event, right? No algebraic or logic operations is permitted as an event. So you can see here positive clock 1 or negative clock 2, or that means we are ORing some of the events, right? Just like events, we are ORing. Okay, instead of only one, we can also have multiple number of connectivities, right? Between the one statement and another, right? The edge transition on each event is to be specified separately. The edge transition on each event is to be specified separately. Okay. So you see here, we have to find the difference between positive clock 1 and positive clock 1 or clock 2. So always here it will be there. Always at the rate positive clock 1 or clock 2. That means if there is any change in the positive edge of the clock 1, it has to be observed, and correspondingly, if there are the changes in the inputs, you have to produce the output. Not only for that, if there are any changes to the clock 2, that may be a positive edge change or else a negative edge change, whatever it may be, it has to be observed, it has to produce the output, right? So now you can see here positive clock 1 or positive clock 2. What does this mean? That means here in the first statement you can see clock 2 is the change in the clock 2 will be observed whether it is from 0 to 1 or 1 to 0. But in the second case, the changes will be observed for clock 2 only for changes that goes from 0 to 1. Okay. Okay. So positive clock 1 means up to this is part, some part. Right, past edge clock 1. Only this is one clock regarding, this is another clock regarding. But you can see this total thing is for one clock and this total thing is for another clock. Okay. So the positive transition for a register type single bit variable is changing from 0 to 1. Variable is logic variable. It is a transition from false to 0. 0 to 1 transition means 0 to 1 transition means in the logical, if you think, it will be changing from false to true, right? Okay. So positive transmission you can see it will be of three varieties. But maybe from 0 to 1 change, generally we will be thinking only of this thing. 0 to 1 change is nothing but the positive of the clock. Not only that, if there is change from 0 to x or z, right? Or if there is any change in the transition from x to 1, x to z or x to 1 like this. What does this mean? So here you are seeing the strength of the signals. You are seeing the strength of the signals. X is the unknown value. Z is the high impedance value. 1 is the strong one. So if there is any change from 0 to x to z, sorry, x or z to 1. Okay. If we don't have exact zero values. Okay. We don't have exact zero values. If that unexact zero value, that may be x or z, if it is changing from that particular x or z position to the 1, then it is also called as a positive edge transition. Right. The similar fashion, the negative edge transition also, where you think that generally it is regarding changing from 1 to 0 is nothing but the negative edge clock. Not only that, if one is changing from 1 to x, 1 to x or 1 to z, that is also called as the negative edge transition. And not only that, x or z, whichever it may be, if it is changing to 0, then it is called as the negative edge clock. Okay, negative edge variable. So the event specified is in terms of multi-bit registers. If the event specified is in terms of multi-bit registers, only its least significant bit is considered for the transition. Okay. If there are any other changes in other bits, they will be generally ignored, right? Okay. Only its least significant bit will be considered for the transition, and change changes in the other bits will be generally ignored, right? So the event based flagging of a block, event based flagging of a block is applicable only to the always blocks. You can see here. So generally, tool, the latest tool of this Verilog, instead of using R, They can also use the comma. If there are any changes on A, comma B or comma C, means A or B or C. So all of them are same. Okay. We have some examples also from versatile counter. So they have given some examples with the help of some versatile counters. Okay. Simple design. So okay, we'll see the examples in the next class. Okay, wait a bit.